Hi, everyone. Thanks for tuning in to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. As a refresher, I'm a senior product marketing manager with Siemens with over 3 decades of experience, and I'm an industry-acknowledged subject matter expert in PCB design. I'm also chairman of the Printed Circuit Engineering Association, PCEA. Joining me today is Andre Mosley, marketing development specialist with Siemens. Andre, thanks for being here. Can you give some quick introduction?
Yes, Steph. Thanks for having me. I'd be happy to. I've worked for Mentor Graphics, now Siemens EDA, for about 25 years. I started off as a consultant, focusing on component and library technologies. Then I transitioned my roles into both customer and product marketing. And now my role is market development. And that is to say I'm focusing in on electronic integrations and data management concepts that help our customers align their business needs to our robust Siemens portfolio.
That's great. That's great. So on our last episode of the Printed Circuit Podcast, we talked about the road to resilience and how we can enable that transformation in 3 phases, which is knowledge, intelligence, and optimization. The first being knowledge. Today, let's dig into phase 2, which is intelligence. When I think of intelligence, we look at this in respect to it's about further component insights that enable actions that solve for both cost and risk. This allows the enterprise to adapt quickly to any supply chain disruptions. Andre, how do you think intelligence enables resilience at the point of design?
That's a good question. I think the first thing is to kind of tackle what does it mean by resilience? And that's really kind of the capacity to recover quickly. And in the PCB world, I call it kind of PCB process toughness. And my analogy to that is kind of how you weather the storm. And living here in Florida, of course, I've learned how to do that. And realistically, we're seeing new storms in the PCB industry unlike we've ever seen before. Typically, when you talk about supply chain, over the history of supply chain, we've tried to be hyper efficient. So in the analogy of the storm, when I go to the supermarket to go pick up toilet paper, they only have so much for a certain amount of time. But when a weather event occurs, they run out of inventory, right? And that's very similar to what's happening in the PCB industry, where this hyper efficiency has really led to hypersensitivity. So the smallest interruption can be a challenge. And so when you talk about intelligence enabling resilience, it's really part intelligence being able to understand and predict the weather, right? I need to know what's going to happen. And so the earlier I can predict the weather, I can get that part intelligence to my engineers so that they can make the right design decisions. And so it's part intelligence. It's the ability to not only search in the databases that I'm used to seeing today, but it's doing extended searching that provide me some additional component information. It allows me to maybe take my design and do things like a bill of material analysis or even compare against different parts. So if there's a weather event and I know that I'm going to be out of toilet paper, is there another option on the table, right? The ability to kind of do a comparison of those different parts and also do some sort of risk alerts, right? So again, I want to get that weather alert like we do on our cell phones when there's going to be a problem. I need to translate that into the PCB industry so that I can get that intelligence and then again, maintain that resiliency and be able to recover quickly. And if you don't have this up front, it can be extremely expensive to recover. And so, Steph, I know you've worked in the mil-aero industry, and I'm sure you can confirm that it takes a long time to recover when you don't have this information.
You're absolutely right. I would tell you, in my last 13 years or 12 years before I transitioned over to Siemens, especially in the last 2 years, one of the last projects I worked on before I left, the supply chain pain is what I refer to. It just hit us hard. I mean, when you think about how many times within the process of designing during the design cycle, we had to stop, take a step backwards, and then go forward. But it was like 2 steps back or one step forward. And that iterative process just took so much time. And time is money. You talk about schedule time and then the additional costs of unexpected hours of redoing steps over and over. It was just brutal, not just for me, but for the entire team. And like I said, I refer to it as the supply chain pain. It takes time. You think about when you submit a part request could take, at an enterprise level, could take up to 3 to 5 business days to get a part released in the system. The component engineer is the first person that looks at it. He or she decides whether it's available or not available. Does it meet all the requirements, the specs that are necessary to get released into the system? If it doesn't, it gets rejected, and the double E's got to go back and research this part and make the decision. Do I hope to find another part, or do I redesign it with a different circuitry, or do I eliminate that feature entirely? And it's not just him making that decision, it's the project team. And it's a negative ripple effect that happens over and over within the process. And today, with what we're seeing in supply chain with the disruptions, we are all feeling this pain. So, like I said, I can attest to it. It's real and it's there. And many of us are definitely chewing on it. You know, Andre, since you've started in the industry, how have you seen supply chain business challenges evolve over time?
It's kind of funny. Both you and I have kind of a similar history. It's a long, valued history, and so when I started in the industry, a lot of the problems it wasn't that acute. The biggest problem back in the day may have been ROHAS, meaning that you were just trying to make sure that your components met a specific requirement. Maybe it was also cost, but lead time was not the biggest challenge because you had enough leeway to kind of do your design work, then send a bill of material over to component engineering and have them procure it and identify that. But now, like the challenges you spoke earlier, this is really becoming a huge issue with our customers, right? Lead time, availability, and even counterfeiting, and the need to make those changes very quickly, right? The world has exponentially sped up on us, right? So even sharing electronic information back in the day when we first started, they barely had computers. And so sending data electronically was not as important. Now in the day of Amazon, you expect to have a result within 24 hours. And so in the PCB industry, we have to share that electronic information a little bit differently, right? Not just exporting out some format and then sending it over the wall. You need to have a cohesive environment. And so we need to have more and more connected solutions because we have more and more connected devices that require more and more electronics. So for example, my refrigerator now can tell me if I'm out of food. And it's a highly competitive market. And as you suggest, redesign is expensive. So now when a component engineer tells me I can't get that part, I just spent weeks, if not months, designing this and simulating, right? So it's not just I can't get the part. I've got to re-engineer this, and it becomes extremely expensive. Steph, I'm sure you've experienced a lot of these types of challenges, specifically at Mil-Aero. And as your role as chairman, how do you see this affecting the three perspectives of design?
From the perspective as chairman of PCEA, where the whole essence of PCEA is collaborate, educate, and inspire, the fact is, as board designers and circuit engineers, there's three competing perspectives that we have to address simultaneously in order to be successful in designing boards, which is layout solvability. That's where you're solving to place and route your parts and any connections in any circuit, whether it's a standard or HDI, as well as at the same time, you've got to master your CAD tool while you're doing this. Then you have your signal integrity or your performance, whereas your signal integrity, power delivery, your thermal, EMC stuff, it's the performance of the board itself. The third leg or the third perspective we are addressing is your manufacturability. Design for manufacturability, design for producibility, where you want to consider producing high yields at lower costs. And in the end, the goal when the designers are attacking their boards is to meet these three perspectives. And you're going to have to make decisions where it's a give and take. And in the end, your goal is to make this revision one work. That's the ultimate goal. And it's tough if you are doing this, but you don't have the insight to the component details from supply chain. And this is where I feel what we have been missing all along is that part intelligence at the point of design. I can tell you, if we had this intelligence at the point of design, it would have saved so much money and so much time and so much heartache. And at PCB West this year, that was one of the discussions that you would hear in the hallways and in between the classes, even some of the classrooms. I know I discussed this in my industry best practices session where I covered this as well. And my discussion with Rick Hartley, Susie Webb, Mike Creedon, Thomas Chester, Dan Beaker, and Ben Jordan, it's there. And this is stuff that's in our face and we got to deal with. It's definitely a challenge nowadays. I mean, board design has definitely evolved. It's not like in years past. When we think about experience with working with customers and all over the globe, especially, as we evolved into the global days now, where COVID has showed us is that we can be effective with global teams. What are some of the more interesting customer examples that with respect to how supply chain resilience has affected them or how they're evolving with supply chain? Or do you have any experience that you can share?
Yeah, I do actually. I'll leave out a couple of customer names, but it really goes to the give and take you talked about earlier, right? Where you have to make revision one work. given the lack of insight, what are our customers doing? And so there's an example I have of a Mil-Aero customer we met with about 6 months ago, where they were explaining to us their supply chain problem, where it wasn't just ICs anymore, but it was actually becoming popcorn parts, right? Resistors and diodes and capacitors. And this represented new challenges. They are a Mil-Aero company, which means they've been in the industry for decades, understanding the impact of not being able to procure parts. But nowadays, it's becoming more and more complex. And so they have to revamp their entire supply chain strategy and how they can provide this information up to their designers. And one of the real world examples that they gave me is that they had an IC that worked at a specific, let's say, a frequency. That specific IC was not available, but as they search for different alternates, typically you'll search for something that meets that threshold but never exceeds. But in this example, they actually went to a higher frequency IC and they were able to procure that one more easily. And so it's not just cost anymore, like we talked about earlier. It's I need to get revision 1 working, as you said earlier. It's balancing that give and take. It's now availability and cost, and can actually build this device that I want to build. Another couple of examples are kind of in the automotive industry, and I've been seeing this recently. I think all of us have kind of experienced, if you've gone out to try to buy a new vehicle, it is very, very difficult. But what we don't also see behind the scenes are places like BMW, where they're actually removing touchscreens from several models, and they're having to work with their suppliers so that they can get these touchscreens into their line of vehicles. And you think of BMW as one of these high-end luxury vehicles, you would imagine that they would all have touchscreens, but actually they will not. Another example is Chevy or GM. They're actually eliminating all of their HD radios and their heated seats because they couldn't get the right chips required for them to do the development. So again, it goes back to what you said earlier. That revision 1 must work, and I have to do this give and take. So we're actually removing functionality so we can meet our timelines because we can't get the devices that we want. Now you mentioned earlier about PCB West. Can you talk a little bit more about what was the word on the street out there? Did you see any customers?
So PCB West was the highest activity and highest attendance that has been, I'd say, in 10 years. It was crazy. The euphoria. The biggest thing is I think people are just excited to get back out to meeting in person. I mean, don't get me wrong, the virtual world is great. It serves its purpose. And what we have found, going forward, the silver lining in COVID is that we can be extremely effective with global teams, and we don't all have to be in the same time zone, the same state, country, whatever. So PCB West had a gathering of industry professionals all from all over. And it was amazing to see, like I said, the volume was at its highest. I don't know, I'm guessing anywhere, and this is a guess, I don't quote me on this, but I'm guessing there was about 15 to 2,000 plus people that attended, which is high. The buzz is how do we adapt in the new world with less resources, tighter budgets, and how do we evolve, and how do we evolve and adapt to what we're seeing with supply chain and the old methodology and the old way of thinking. We've got to evolve from that. I mean, you can continue to do the old way, but you will slowly fall behind and fade away. You have to adapt to the new real. And the new real is that you've got to have this intelligence and you've got to have this foresight at the point of design. And the engineers got to know this and got to have this information to make intelligent decisions from as we unfold. And in the hallways, you'd hear people discussing their issues or what they're running up with. I mean, one of my colleagues, even leading into PCB West, a good friend of mine who owns his own business, he's a double E. I won't mention his name, but he's double E. And a couple of his experiences told me was that running his own company, parts that he's been purchasing that were like $2 are now like $20. Lead times have gone from a few weeks to maybe 52 weeks. It is real, and this is a real problem. And these are the type of discussions and why it's important, in my opinion, to attend industry conferences, because you can't get that kind of integration and that kind of feedback from the industry of how are you guys doing it? What are you guys doing that I can bring back these golden nuggets, bring back to my company or my team, and let's apply this to be successful. This is where, industry collaboration allows us and respectively to be better and more effective. But it does no good if, first of all, if you don't attend and you do nothing, because then the question becomes, what is the cost of doing nothing? That's another thing you got to look at. And then, if you bring these golden nuggets back, but if you don't apply them, or what I mentioned in my best practice session was that the biggest resistance or the biggest hurdles you're going to come up against is internal company resistance within your own culture. The culture within your company, is it open to change or is it resistant to that? And I can tell you, coming from Mill Arrow and several, when I consult, I see a lot of this about regarding internal culture resistance within a company. That's definitely an issue. So yeah, PCB West was hot. You're going to see a lot more with not just PCB, with a lot of other industry conferences that are happening and unfolding today. Supply chain resilience is definitely a hot topic. And you see it in articles, you see it in publications, whether it's PCD&F magazine or I-007 magazine, you see it all over being discussed. So yeah, it's definitely an issue. When we talk about, the solution or where do we go from here, what do we see, the industry specifically evolving to resolve these business challenges? The customers are seeing in terms of intelligence and optimizing resilience. Andre, what do you think? What is your take on that?
Well, it's kind of what you were talking about earlier, right? We now have what I like to call engineering in the new normal. It's not our old engineering environment. And so we touched on some of these topics earlier, but let me go into a little bit of detail. So the first and foremost, it's about intelligence. So it's not just, hey, the intelligence is out there, but giving me almost push button access to that intelligence and availability and pricing and parametric criteria, including models. So I kind of refer to this as a component digital thread. We talk about digital threads within Siemens all the time, right? But a lot of times we focus in on the design digital thread, but the component is really a subset of that, and it's an extremely important piece. And so there's this component digital thread that it's not just the electrical information that we've evolved into extracting and getting from content providers, but it's also the supply chain data. So as I'm doing that design, as I'm choosing that part, I'd like to have that intelligence up front. And if I do find a problem, I want to be able to search internally first, because typically, our local customer databases will have a set of parts that we know that we can procure. But let's just say it doesn't meet my criteria. I need to be able to, once I find that part or I perform the query on the part I want to find, I look in a local database, but I need to extend that, right? I need to extend that out into the industry for the details to give me that part intelligence. So I need to see, what's outside my corporate library. Are there alternates? Can I do some what if scenarios? And when you combine that together, you can do some sort of analysis. Really, if I have a design, I always want to continually kind of audit this design and do that kind of health check to see, hey, am I still meeting my price, my availability, or is there any risk? And so I usually use that bill of material to do that analysis. And again, if I find a problem, I want to be able to compare different parts. Again, not just electrically, but also at the supply chain level. So this part may be, as I talked about earlier in the Mill Arrow example, it might be at a higher frequency or even a higher cost, but in terms of availability, it's readily available. And so I can make those trade-offs that you talked about earlier, right? It's about making sure revision 1 works. It's about give and take. And lastly, it's risk alerts. Because a lot of the times, a lot of these things will happen in the middle of the night and we won't even know the impact of geopolitical issues or environmental issues or just a run on components. I'm not sitting there every day pushing the button to say, do I have a problem? Do I have a problem? I need to have risk alerts. And so if I have a corporate library or have a bill of material, I want to be able to run those alerts and communicate to me to say, hey, Andre, there's a weather event coming. There's a storm brewing and you need to prepare. And so we're really kind of expanding the intelligence across these different areas. It's electronic information, it's supply chain data, and even the models that go along with that so that I can very quickly redo my analysis or my simulation. In terms of your question, where do we go from here? Customers need full solutions, not just the tools. There's plenty of tools out there that can take a bill of material and run an audit, but there's not a lot of solutions out there really to connect all of these pieces together. And this is what's going to allow our customers to kind of weather that storm and create that resilience that we talked about earlier in the face of these growing challenges.
Absolutely, especially when you think about the manual way, the old approach, and what we need to evolve to is, like you say, the digital integration and that thread that's happening.
You got it. Throw it over the wall approach.
Exactly. So with that said, we're just about out of time. So I'd like to wrap up and summarize what we were able to discuss today. Today, we talked about what is intelligence and how it's the second phase on the road to resilience. We talked about the evolution of business challenges and how challenges are only increasing, they're only getting worse. And we talked about a few customer supply chain examples. And lastly, the evolution of intelligence and how these technologies enable resilience at the point of design. So on behalf of my colleague, Andre Mosley, I'd like to thank you all today for your time. And I hope this discussion has been helpful and insightful and understanding how you can get to the road to supply chain resilience. Thank you, and I hope you can continue to tune in and follow me on this Printed Circuit podcast.
Thanks, Steph.